Today we are continuing the coplanar forces again about the moment. Today discussing about the theorem and some resultant cutting point. Both of them we are already discussing here. Now we take any system of force having resultant. Right? Result. Usually there are forces, various forces acting to rigid body, like this. Three, four, various directions. Four. Now here you consider it has some resultant. We say this direction. And we are introducing the theorem. This is a very, very important theorem for find out the cutting point of the resultant for the plane. This theorem says like this here, the system of force acting here, resultant here. Any point, resultant moment. Any point, resultant moment. This one. Perpendicular, then resultant moment for same direction. Right? Resultant moment equal to the other forces moment. Algebraic sum of the other forces moment. Algebraic sum of the other forces moment. Normally, simply we are saying resultant moment equal the other forces moment. This is the very, very important theorem for the coplanar force. Right? Resultant moment equal to the other forces moment. In this theorem using, we can calculate the resultant cutting point. We say simple question, this one. This is square, side length A. This is square, side length A. Right? This is square, side length A. Side length A meters. Right? These forces are acting on it. Here, this direction 3 Newton. Right? This is 3 Newton. This direction 1 Newton. 1 Newton. Again, this direction 1 Newton. 1 Newton. Here 1 Newton. Here again 6 Newton for outside. Here 6 Newton. Right? These are the forces. This is A, B, C, A, B, C, D. This question now, frequently these type questions have in the examination also sometimes. And the first one is the resultant. Resultant and its direction to be inclined to the horizontal. Direction inclined to the horizontal angle. Resultant. Number 2 asks, what is the resultant cutting point at AB? AB cutting some point resultant. When we say resultant this one, this is the resultant, this force, right? This is cutting point N. This should be calculated. AN. What is the AN length? We already calculated the coplanar regarding the coplanar forces. Resolving, calculate the resultant, then again calculating the horizontal angle inclined to the resultant. Resultant inclined to horizontal angle of equal of this angle sometimes. This is the resultant cutting point here, considering here. Right. Now we get, first of all, this should be resolved to x-axis direction equal to see 3 plus 1. 3 plus 1, right? 3 plus 1, only there, equal 4 Newton. Y direction vertical component, y direction 6 minus 1. Here down now. 6 minus 1. 5 Newton. Right. Now draw the parallelogram or rectangle like this. 5 Newton here, this direction 5 Newton. Y equal 5. Y equal 5. X equal how much? 4. Resultant should be this direction. This is the resultant direction. Resultant direction. R. Theta is the angle. Right. Now we calculate R squared equal what that? X squared plus Y squared. R squared equal X squared plus Y squared. X squared 4 squared 16 plus 25. Y squared. Already 41. R squared equal 41. R equal root 41. 41. The direction inclined to the horizontal and theta is equal y over x, y over x, y over x, 5 over 4. Y over 4. This angle, theta is equal tan inverse 5 over 4. Theta is equal tan inverse 5 over 4. Those are the getting some data from this question. Now, second part is what's the result? The result actually not here. Acting on somewhere here, system of forces area. Right? We say resultant acting this direction. Cutting point is the AB, N. N is the cutting point. Now we have to calculate the cutting point distance. A to N distance. We see A to N distance, simple D. When I start the lesson, already discussed what is the theorem, moment theorem. What the moment theorem? Moment theorem. Resultant moment is equal to the other forces moment. This is the resultant. Right? This is the other forces. These are equal. But they equal any point about any point, we say A, resultant moment equal to the other point moment, other forces moment. Actually, resultant in inclined direction, sometimes vertical, sometimes horizontal, sometimes inclined, most of cases inclined. Now our usage, we can say resultant can be resolved to two parts. What the one part? X and Y. What the X and Y giving the resultant. Resultant, instead of the resultant, we can use X and Y also. Y put here. This is Y. Two arrows. Y. This is X. Two arrows. What this Y? Y is called 5. This is 5. Right? This is 4. Right. Then resultant moment taken, we can take these two forces moment also. Why? Instead of the resultant, we are using these two forces. Instead of the resultant, we are using these two forces. Right? Now we get in the equation. What the equation? Resultant moment equal to the other forces moment. That should be using here. Right? About any point. Any point you can consider. Actually, we have to consider some convenient point for easy to us. Right, this one. But the theorem we have to mention here, right? Answer paper also you have to mention the theorem. Resultant moment equal to the other forces moment. Resultant. This say here. Resultant moment. What is the resultant moment? X and Y. Point A to Y, perpendicular direction D. We say D. D we have to calculate. D. Pi D. Y into D. y into d 5d. 5d. 5d equal what that? Other forces moment. Other forces we have to take. Previously, these type of questions we have already done, right? Moment questions. A. These two forces were there. Neglect. These forces going through A. Resultant also this X force going through A, X we are neglecting. This one only having. This one actually minus moment. This direction, clockwise. We are getting anti-clockwise. There is a minus 1 over A. A is the side line. Right? Minus A. Minus A. This is also 1 again, minus A. Right? Clockwise direction this one. Minus A. Then D is equal for that. Minus 2A over 5. What is the minus sign thing? Actually, if we draw the square and resultant like this one extend to backward direction. In this length, actually n, this is here 2A over 5, minus sign here. This is the resultant direction. Root 41. Right? We have to, after finish your question, you have to mention this one very simply, this one. We have to put here. Right? This is the simple question about the resultant cutting point. Now we get another question. The number 2 question we are getting the triangle. Right? And how to get the triangle? This is the question. This is a triangle. ABC triangle. ABC triangle. ABC triangle. This side 10 Newton. Here 5 Newton. Here again 10. This is equilateral triangle, 60 degrees, 60 degrees, 60 degrees. This system have resultant. We say resultant like this. This direction. We don't know actually. We have to calculate this direction. This is n cutting point. They ask what is the resultant cutting point of the system of forces or B in distance. What is the B in distance? We say here D, right? Now what is to do? First of all, to solve the forces, calculate the resultant and direction, right? Now we solve the forces, x-axis direction equal, we say x-axis this one, this x-axis, perpendicular here, y-axis, right? This is the origin, right? Now, solving 10 coming first, then this coming 3 cos 60 plus this is solvable. 3 cos 60. 3 cos 60. This one minus 5 cos 6. Minus 5 cos 60. Cos 6. Now we get it here. 10 minus 2 cos 60. 2 into half. Cos 60 half equal 9. 9 Newton. In the y direction is same one. This draw the perpendicular to here like this. This is 30, this is 30. Right? 30, 30. Right? So this is also convention. In y direction, this one, 3, what that? Sine 60. 3 sine 6. 3 sine 6. This is positive. This is 5 sine 60. This is positive. 5 sine 60. Already 8 sine 60, 8 into sine 60 root 3 over 2 equal 4 root 3. Right. Resultant. How to get the resultant? Result we can get like this. To x and y you have to represent that background like this. X equal 9, y equal 100, 4 root 3. Right? 9 here like this. Bigger 9. 9x equal 9. This is 4 root 3. 4 root 3 y equal. Go here. This is the resultant. Right? This is the resultant. Right. This is the angle for theta. Theta. Now we get it after calculating like this. What are the system? You remember this thing? R squared equal x squared plus y squared. X is equal 981 squared plus 4 root 3 squared. 16 into 3, 48. 48. Already 929 to 29 to 229 Newton is the result. Right? Tan theta is equal y over x, but that 4 root 3 over 9. This is completed part 1. Now we have now they are asking this thing. What is the resultant cutting point of BC? BC is cutting point. We have to calculate BC cutting point. How to get the BC cutting point? Like this. Resultant moment equal to other forces moment. Instead of the resultant, we are using x and y. Y 4 root 3. Enough only using y or y now. Other don't know to put here. Why we are very accepted neglecting. Right? This is the y. Now, moment taken about B. Moment taken about point B. What is the moment about point B? Resultant moment equal to other forces moment. This is the theorem, famous theorem. Anticlockwise direction we are taking. Resultant moment is 4 root 3 into D. 4 root 3 into D. Equal other forces moment. What are the other forces? What are the neglecting forces? Neglecting forces are here. This and 10, 3. Going through this moment taking point. Only this force only come. What is this force? Very easy to calculate. Draw some small of this one, this one. Opposite triangle, this one. This length is actually given 4 meter. 4 meter. Right? 4 meter length. Means 4 meter length, this side length. 4 sine 60. 4 sine 65 into 4 sine 60. 4 sine 60. Equal 5 into 4 into sine 60 root 3 over 2. 4 root 3. D is equal 2.5 meter. What are these things? This is a 4, then 4.2.5 maybe here. This is the actual direction. You put a small diagram and put here like this direction. resultant. This is N point. This is B. This length is equal to 2.5 meters. This is the resultant cutting point. Okay. Next day we will continue these lessons. Now we thoroughly practice this system. All my video you have to follow. Then you can so many things learn about these things. Okay. Thank you very much for the watching the video.